Hi everyone, I'm Abhay Upadhyay, software engineer at Akave, and today we are going to hack the data layer for AI together with Filecoin and Akave. Now, before we move ahead with this workshop, let's discuss the goals of this workshop. The goals of these workshops are learning decentralized storage concepts, learning how Filecoin and Akave works, and how does Akave complement Filecoin, what is Akave and Akave O3, how to interact with your data in an agentic way, next steps and what to build with Filecoin and Akave during ETHGlobal Prague hackathon. Now, before we dive into this workshop, I would like to ask a question. Why do we even need decentralized storage for AI? So it's quite simple. Traditional storage is fragile. It's centralized, prone to failure, and easily censored. In AI, we are generating tons of valuable sensitive data, and it needs better protection. So what do we gain from decentralized storage? What we gain is resilient and fault-tolerant storage, content addressing over location-based addressing, data sovereignty, that is, you own and control your own data, censorship resistance, and participation in a decentralized data economy. That is, you actually get paid to store data and sell your data. Now, let's clear a common misconception before moving ahead. IPF Filecoin is not IPFS. Now, what do I mean by that? Let's differentiate between IPFS and Filecoin. IPFS, the purpose of IPFS is decentralized file sharing and retrieval, whereas the purpose of Filecoin is reliable and permanent decentralized storage with incentives. So the storage mechanism in IPFS is storage of file across network of nodes, but in Filecoin, storage of files across the node that provide storage for a payment. Incentives to run an IPFS node, you don't get an incentive. It's completely on voluntary participation. Whereas when you participate in Filecoin, uh, the storage is incentivized and you are paid in cryptocurrency that is Filecoin. So data persistence in IPFS, as the participation is voluntary, there is no guarantee that the storage provider would store your data, but in Filecoin, as it's incentivized, the SP has incentive to store your data. Now let's see, where does Akave fit in all of this? So as we discussed ahead, Filecoin introduces incentive-based storage layer. On top of that, FVM complements it with a programmatic storage. That is, you can write smart contract that can interact with the state of your storage directly. How does Akave complement what's already built on Filecoin? So on Filecoin, when you store your data, it's sealed, and this sealed data is hard to retrieve because of uh, the compute costs in unsealing. So it takes some time to get this data back. So we also call this form of storage warm storage. But Akave is a hot storage layer. We do not seal the data. We just everything is client side. You can encrypt your data and store it on Akave as it is. We do not make any changes to data, and it is highly accessible data layer. You can connect to the node closest to you and retrieve your data really quickly, comparable to cloud storage infrastructures. Now, Akave delivers the best of blockchain plus Web2 compatibility. Now, what does Akave offer? Akave offers an S3 compatible API that works with all your Web2 applications that already uses S3 packages. Up to 80% cost savings because of no or low egress costs. On-chain indexing, that is, your data is 100% traceable on a Kave chain itself. Data wallets, as AI agents come into play, the data itself is linked to a wallet. So your AI agent can have access to a wallet that can control the data. So AI agents can act agentically on data. Now let's see how this all works, how Akave works under the hood. So when your data enters through a client application, be it Akave O3, Akave CLI, Akave JS wrapper, or Akave link, it goes through our Go SDK. Then the object itself is stored on our contracts, and the data is chunked and erasure coded across all our hot storage layers, that is Akave nodes. And after these nodes collect 32 gigs of data, they seal it and store it on Filecoin. So your data is erasure coded and then backed up on Filecoin. So there's no way you're going to lose your data. Now let's look at data security framework. This is just to zoom in into this specific part. So if you look here, when you upload your file, it's split into 32 megabits chunks. Each chunk is split into a data block which is less than or equal to 1 megabit. Now this is encrypted using encryption key or your private key, which is client side. Now this data blocks are erasure coded. That is, parity blocks are added to this and stored on Akave nodes. So if a few of the nodes do go down, we can recover the original data itself using Reed Solomon recovery and get the original file back. Is Akave O3. Akave O3 is our S3 compatible decentralized object storage layer. It brings the best of Web2 compatibility with Web3 transparency. Benefits of Akave O3 are plug and play for any apps via S3 API, low egress cost, on-chain indexing, everything that we talked before in a familiar way. Now let's look at Akave O3 demo. Before starting O3 demo, I'd like to point out you guys to docs.akave.xyz or docs.akave.ai, and you can go through Akave O3 setup to set up your CLI. For this workshop itself, I'll be assuming that the AWS S3 CLI has been installed and Akave O3 environment has been set up. So I'll go ahead with the O3 demo, assuming the following. Okay. So also one more thing, to get this access key ID and Akave X secret key, you can visit our booth at ETHGlobal or ping us on Discord channel. We'll reach out to you and provide those credentials as it is still in release candidate phase. So I'll move myself here. Now, as you can see here, I'm using Akave O3 with AWS S3 CLI. So it works similarly to AWS S3, just replace the endpoint URL with Akave O3's endpoint URL, and it just works. So these are all the buckets I currently have. Let's make a new bucket. Let's make a bucket named ETHGlobal demo. And we have successfully created the bucket. Let's list the buckets again to verify that. So as you can see here, we have the global bucket created. We can also create some random file to upload to that bucket. As I'm creating a unique random file of 10 1 MB. Let's do ls. As you can see here, we have 1 MB file right here. Let's upload this file to the newly created bucket, Akave S3 cp /test.txt. Okay, as you can see here, the data is being uploaded. Yeah. So the data has been successfully uploaded to Akave O3. So that's it. It's as easy as using AWS S3, but instead of using cloud infrastructure, you are using now decentralized cloud infrastructure. So let's list the files in the bucket, and we can see right here the test.txt that we just uploaded. Now I'll make a download directory and download the newly created file to that download directory to show that the download command works. So every single command that I'm using here is similar to AWS S3. There are millions of documentation out there, so you can search for every single command you need, or you can go to Akave's doc and see every single command that is supported by Akave O3. So that's all about Akave O3, and let's move ahead with our workshop. So before going through MCP demo, I'll recommend everyone to go through this model context protocol documentation developed by Anthropic uh, to learn more about MCP. So now I'll be demoing MCP with a local LLM. So your data never leaves your PC and all the compute is local. Now for this, prerequisites are having Olama installed and having a small model that can run on your PC like Qwen 2.5 with 7 billion parameter already pulled. If you don't know how to do that, you can go to olama.com and can download models from there, or download Olama first, then pull the models from here. Okay. Uh, to run an MCP server, but you can go through our code at Akave AI/Akave MCP repo, where you can find a step-by-step guideline on how to add it to Cloud Desktop 2. I'll just be doing this usage with local LLM part. So before starting, we'll need an MCP configuration. So I'll use this configuration. Let's see what exactly is in this configuration. As you can see, this is just a normal JSON with an npxy Akave MCP.js with all your Akave credentials here. This is just a test credential, so uh, please do not copy this. Uh, if you need these credentials, you can reach out to us on Discord and we'll provide you with fresh one. Now I can just go ahead and run this MCP host. So what we are doing right here is utilizing a local LLM to run an MCP client. MCP server comes from npx, that is Akave MCP.js, that is a published package already. You can go to npm.js and take a look at it too. npm.js. You can go ahead with Akave MCP.js. So this is where we are pulling our uh, uh, MCP server code from. So all you need to run this MCP client is this JSON file. Installing MCP host, the steps are given over here. You just need to do a go install of MCP host and have Olama installed. That's it. And you are ready to run a local LLM that can connect with your on-chain storage. Let's see. Now let's ask this AI list buckets I have in Akave. So as you can see, the assistant has responded with following buckets, and we can also see ETHGlobal demo that we just created using O3 API, thus proving that it is connected to the same O3 instance that I was using with AWS S3 CLI. Now we can ask it to go in my blocks, look for files in this bucket, As you can see, it has listed all the files in the bucket. That is these three files. I'll take one of these files and ask it to read it. Read file. As you can see, it has written the contents of brief blog post txt. It shows how you can interact with your data in an agentic manner. The sky is limit. You can go ahead and fork our Akave MCP repo and take it further, create multiple features that even I cannot think of. So go ahead and hack with it. If you have any questions, reach out to us on Akave Telegram, or any questions related to Filecoin, you can ask it on Phil Builder's channel. Thank you.